Hello and welcome. This is your lesson on 9.1 Mathematical Patterns. Vocabulary. Sequence. A sequence is an ordered list of numbers, and each number in the sequence is referred to as the term of the sequence. So, for example, you're going to have your first term, which is going to be some number a sub n. The second term will be referred to as a sub 2. This is subscript. Third term, a sub 3. And then all the way dot 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 n minus 1 will be the term before the general term, and then n plus 1 would be the term after it. So this is before the nth term, after the nth term. Also, what else would I tell you? So if I had a list of numbers, for example, 1, 7, 13, 19, dot, 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 I would basically be calling the 1 my first term, so that would be my a sub 1. A sub 2, the second term, would be 7. A sub 3, the third term, will be 13. And a sub 4, the fourth term, would be 19. So this is your first, second, third, fourth term. Makes sense, but it's just a little bit of new notation for you all. The next thing I would love to tell you about is explicit formulas. These describe the nth term of a sequence using the number n. For example, if we have the sequence 3, 6, 9, and 12, well, this is my first term, my second term, my third term, and my fourth term. The explicit formula of the nth term is a sub n equals 3n. So that means this is 1, the first term, this is n, first term. So a sub n is 3. So you're kind of asking yourself, okay, what do I need to do to the n, 1, to get 3? What do I need to get to the n, which in this case is 2, to get 6? And you would have to multiply it by 3 each time. So your explicit formula is a sub n equals 3n. Your recursive formula, on the other hand, relates each term after the first term to the one before it. So instead of just thinking, what do I need to do to the n, the number of the term, to get the term, now you're just thinking, okay, what do I need to do to 3 to get 6? What do I have to do to 6 to get 9? So on and so on and so on. And so for this example, well, you're basically just adding 3 each time. So a sub n minus 1 refers to the term before it. This is supposed to be a small n. A sub n. So in order to get the next term, I just add 3 to the previous term. This n minus 1 is basically saying the previous term. Okay, so we'll talk more and more about explicit and recursive formulas as we start dealing with them. But first, just to get a little bit more familiar with it, they want us to find the first 6 terms of each sequence, the first 6 terms. So the first term of the sequence is going to be known as a sub 1. Then we're going to find the second, third, fourth, fifth, and sixth. So a sub 1. So that means wherever I see an n, we're going to put a 1. So a sub 1 will equal 5 times 1. So the first term in the sequence would be 5. A sub 2 would be, I'll just do it here, 5 times 2, which is going to be 10. Kind of see the pattern. The third term will be 3 times 5, which will be 15. The fourth term will be 5 times 4, which is 20. The fifth term will be 5 times 5, which is 25. And then your sixth term will be 30. So the first 6 terms, first, second, third, fourth, fifth, and sixth terms are now listed. Do the same right now for part B, where you're basically, instead of organizing this in an XY table, you're just making a list of numbers, and that's all that you have to do. So for your first one, for this one, a sub 1 is equal to 1 squared minus 1, which is 0. A sub 2, 2 squared minus 1, 4 minus 1, which is 3. And then continuing on. Go ahead and press pause, fill in the pattern, and then unpause to check yours. Okay, not sure if you pressed pause or not, but if you didn't, you're just kind of a cheater. 3 squared minus 1, I got 8. 16 minus 1, 15, and then so on and so on. So just plugging in, and that's your list of the first 6 terms of this sequence. All right, the next thing that we would like to do is just to show you now how to write a recursive rule for each sentence. Recursive. So remember, recursive means that we want to relate a sub n in terms, or write it rather, in terms of a sub n minus 1. So basically what you're asking here is, what do I need to do to the first term to get the next term? What do I need to do to the first term to get the next term? So what do I need to do to 1 in order to get negative 2? Well, it looks like I just have to multiply by negative 2. Let's check it for each term just to make sure. Times negative 2, times negative 2, times negative 2. Love it. So a sub n, my general one, is going to be negative 2 times a sub n minus 1. Notice here, this is a subscript. It means it's smaller and in the right corner. Okay, so for part B, same question. What do I need to do to the first term to get the next term? And then what do I need to do to get the next term and then the next term? So you're looking for mathematical patterns. That's the name of our section. What do you need to do to negative 14 to get negative 8? Well, there's nothing I could multiply by unless it was some random weird fraction. So let's try to add something to both and see if we can get that. I think negative 14 plus 6 gives me negative 8. Negative 8 plus 6 gives me negative 2. That's good. And then, so here's the thing: if you have some issues, excuse me, with negative numbers, look at the positive ones. 4 to 10. What do you have to do? Add 6, and then see if it works for all your other terms. So, if I'm starting with a sub n, in order to get the next term, excuse me, if I have a sub n, I'm trying to figure out what do I need to do to the previous term to get a sub n. And basically, starting off with a sub n minus 1, which is the previous term, I need to add 6. And that is my recursive rule. Now we're going to go to the explicit ones. And now for this one, it's a little bit different because now we're asking ourselves, what do I need to do to the n to get a sub n? It's a good question. Again, what do I need to do to the n to get a sub n? So it helps to see the n's in order to make a connection there. So for the first term, the n is 1. This is the second term, the third term, the fourth term, and the fifth term. What do I need to do to 1 to get 3, to 2 to get 5, and to 3 to get 7? Not seeing it right off the bat, correct? I'm not. But let's look at the connection between these two numbers. Looks like I'm adding 2, and I'm adding 2, and I'm adding 2, and I'm adding 2. Now, whenever you're adding by the same thing every single time, it's going to be 2 times n. This is because it's linear. If it was like, if you were going to graph this, you'd get a line. But that's not the point of this lesson. So if you're adding 2, that does not really help me out, Miss Fitzgerald. So 2 times 1 is not 3. 2 times 1 plus 1 is, though. And then, so from here, you just kind of see, does that work? So first, I saw the connection between adding 2, adding 2, adding 2, and adding 2. So if I'm adding by the same thing in connection to the n, it's going to be 2 times that number. So 2 times 1 is 2, then I need another 1 in order to get 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 plus 1 is 7, and then it continues on. So a sub n equals 2n plus 1. Now, the other part of this is to find the nth term, the 10th term, excuse me. So a sub 10 is equal to 2 times 10 plus 1. This way, I don't have to keep adding 2, add 2, add 2, add 2, add 2. I can just plug it into my formula to get the 10th term. So 2 times 10 is 20, plus 1 is 21. That's your 10th term. So 2 answers, 1, 2. All right, looking for connection for part B, 1/2, 1/4, 1/6. Well, the numerators are all 1. That's great. But let's see it. This is the first, second, third, fourth term. What do I need to do to 1 to get 2? Looks like multiply it by 2. What do I need to do to 2 to get 4 times 2? So this isn't so bad. A sub n is equal to, all the numerators are 1, so I know it's 1 over something, because that's not changing at all. And then I looked for a connection between 1 and 2, 2 and 4, 3 and 6, 4 and 8, and it's just multiplying by 2. So that's my explicit formula. And then for the 10th term, a sub 10, that's 1 over 2 times 10. A sub n, a sub 10 is 1 over 20. Two answers. Okay, the next thing that they would like for me to do is to find the 8th term of the sequence. Find the 8th term of the sequence. And so, first thing I want to do is, because I don't want to keep multiplying out and multiplying out and multiplying out, I want to try to get myself a rule. So I'm going to go for an explicit formula for this one, and then that'll help me out a little bit. So here's my first term, second term, third term. And again, you're just trying to make connections. 1 to 5, 2 to 25, 3 to 125. And if you know exponents, you know 5 to the first is 5, 5 squared is 25, 5 cubed is 125. So my rule is going to be a sub n. I'm also noticing here that the 2's, the numerators, they stay the same. So it's going to be 2 over something. And then what was I doing from one to the other? Well, I'm exponentiating. So 5 to the n. That's your rule. So then they asked also the question, what is a, well actually that's really the only question, a sub 8. So this is going to be 2 over 5 to the 8th. Now, I probably would give you a more reasonable answer to where you could multiply that out, but for this case you can leave this as a power because it's a lot to multiply. You're going to get a really, really huge number. Okay, so here's your next one. It is 8, 11, 14, and 17. What I would like for you to do right now is to truly press pause after I finish the sentence and try to give me a rule for this one. What do you notice about the numbers, and what's a rule that you might use to express them? Okay, so I just saw that for the first, second, third, fourth term, what I'm doing is I'm adding 3 each time, and so if I'm adding 3, then that tells me it's going to be 3 times n. 3 times 1 is 3, but that does not give me 8. I would need to add 5 to 3 to get 8. So then I said plus 5. I just added that on at the end. 3 times 2 is 6. That doesn't give me 11. 6 plus what? Here's what's going on in my head. 6 plus what gives me 11? 5. And then I just checked it to make sure. 3 times 3 is 9, plus 5 is 14. 3 times 4, so on and so on. So that works. The question, though, was a sub 8, and so that's going to be 3 times 8 plus 5. So my 8th term in this sequence is going to be 29. All right. And for your next problem, use the given rule. So they give us the rule. That's great. I know some of you are relieved. To find the 4th, 5th, 6th, and 7th term of each sequence. So a sub 4 is what you're looking for. A sub 5, a sub 6, and a sub 7. Plug in each of those numbers for n, and then tell us what you get. Okay, so if you trust my math, just plugging in, and if you didn't show your work, go ahead and press pause now and copy mine. But the 4th term is 27, the 5th term is 48, the 6th term is 75, and the 7th term is 108. Okay, now they would like for us to find the next 2 terms of each sequence. So I have 4, 8, 12, 16, 20. It looks like I'm adding 4 each time. So the next 2 terms would be 24 and then 28. Looking for patterns there. Then they would like for me to write a formula for the nth term and identify it as explicit and recursive. Now you have a choice at this point, and you can do recursive, which is where you're looking for the a sub n minus 1, or you could do explicit. I'm going to show both. You pick which one you'd like to do, press pause, and then I'll show you the answer. You can check to see if you are correct. But pick one when you do your homework, and then check to make sure it's right. Okay, so since I was just adding 4 to each term, it's just a sub n minus 1 plus 4. So I add 4 to the previous to get the next term. And then my explicit one, because I was adding 4 each time, it's just 4 times n. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, so on and so on. So either way, you should have one of these written down on your thing and be able to tell. If you see it a sub n minus 1, you know it's recursive. If you just see 4n, you know that it is explicit. Your next slide has your homework assignment for tonight. Enjoy and do well.